Good morning, students, and this is the 6th Mpmc class, online class we are giving, and here we are going to discuss the internal architecture of 8086 microprocessor, that is the block diagram of 8086 microprocessor. In the last class we have discussed about the introduction of the microprocessor and microcontroller, and the previous classes we also discussed about the modes of operation and pin diagram of 8086 microprocessor, and in this class I am going to explain about the architecture of 8086 microprocessor. Before going to study the programming for the 8086 microprocessor, we need to study the internal structure of the 8086 microprocessor. In internal architecture of 8086 microprocessor, we are going to see some registers, we are going to see some flag, we are going to see some operands, we are going to see some instruction byte, like that. We have to study all these things as the internal parts of microprocessor. Microprocessor is nothing but it is a CPU, it is a central processing unit. And before going to study the programming for the 8086 microprocessor, we must study the internal structure of 8086 microprocessor, that is nothing but architecture of 8086 microprocessor. This is the diagram which describes the internal architecture of 8086 microprocessor, and this internal architecture of the 8086 microprocessor mainly divided into two parts. One is BIU, another one is EU, and these two divisions are represented by with the dotted yellow color lines, and this first part is BIU and the second part is EU. BIU is nothing but bus interface unit. That means it is going to interface, this is going to interface with the outside microprocessor, that may be memory or input output ports, and whereas execution unit, it is going to execute the instructions which are fetched by the bus interfacing unit. This here in the execution unit, instructions will be executed by the processor, whereas here bus interfacing unit, it is going to interface with the outside world, that may be memory or input output devices. So as we discuss this complete 8086 microprocessor internal architecture is mainly divided into two parts. First part is named as BIU, that stands for bus interface unit, and the second one is execution unit. And we are going to study what are the functions of bus interfacing unit and what are the functions of execution unit. This bus interfacing unit and execution unit combinedly they perform the operations in order to increase the speed of the processor. Speed of the processor is nothing but number of instructions executed per unit is called, it is the speed of the processor, and this is number of instructions executed per a unit is called throughput. Throughput is nothing but the number of instructions executed by 8086 microprocessor in a unit, that is called throughput, and that throughput is dependent on the bus interface unit and execution unit, because bus interfacing unit and execution unit combinedly they do the operation, that speed of the operation is completely dependent on these bus interfacing unit and execution unit. And here this complete 8086 microprocessor, that is CPU, it is nothing but a microprocessor is nothing but CPU, and this completely divided into two parts, bus interfacing unit and execution unit, and this top part is called bus interfacing unit, and here the bottom part is nothing but it is a execution unit. And in this bus interfacing unit and execution unit, we are going to have total 14 number of 16 bus buses, because in the features of 8086 microprocessor we have discussed, this is a 16-bit processor and it has the 20-bit address bus. Likewise, and one of the important feature of 8086 microprocessor is internally this 8086 microprocessor can have the 14 16-bit registers, and here that 14 16-bit registers are classified into 5 classes. First is general purpose register. General purpose registers, this AX, BX, CX, DX. This is accumulator register, base register, code register, and data register. These 4 are combinedly named as general purpose register. And the another part of these 14 register, that is segment register. There are 4 more segment register, that is extra segment register, code segment register, stock segment register, and data segment registers. And the third classification of these 14 register, that is pointer register, index registers, that is index pointer register. This is a source pointer register, and this is a base pointer register. And the next one is, the last one is the index register, that are source index registers and the destination index registers. And combinedly all these 5, one more type of register, that is a flag registers, and these 5 classes will comprising of the 14 16-bit registers in internal architecture of 8086 microprocessor. And coming to the 2 main parts of the 8086 microprocessor, that is a bus interfacing unit and a execution unit. I am going to discuss what the functions of bus interfacing unit. First one, the bus interfacing, the main functionality of the bus interfacing unit, it is going to interface the processor to the outside world, that may be memory or input output devices. This is a bidirectional bus. This is going to have the bidirectional bus. That means in the pin diagram of 8086 microprocessor we have studied, that is a bidirectional bus can carry the information of data and as well as address. During the T1 cycle it can carry the information of address, and during the T3 and TW it is going to, same bus is going to carry the information of data. So that this is a bidirectional bus. The first important function of bus interfacing unit, that is nothing but it makes the interfacing of 8086 microprocessor to the outside world. And second important function of 8086 microprocessor, it sends out address of memory to address of memory or input output port. That means this bus interfacing units sends the information of output address location of memory or input output ports. And second one, it fetches the instructions from the memory, so that this bus interfacing unit is going to fetch the instructions, and these instructions, that 6 instructions bytes are going to stored in the queue, and these instruction will be taken by the execution unit. While the execution unit executing the current instruction, the same execution unit is going to take these instructions for the next execution, and this process of taking the next instructions while it is executing the current instructions is called pipeline process, pipelining. Here the second important function of 8086 microprocessor is it fetches the instructions from the memory, and this bus interfacing unit is interfaced with the memory, so that this bus interfacing unit is going to fetch the instructions. It are going to stored in, that is in the instruction stream byte queue, and this will be taken by the execution unit. While it is executing the current instruction, it is going to take these 6 instructions byte, so that this process is named as pipelining. And coming to the next one is it reads the data. The function of the bus interfacing unit, it reads the data from the memory or input output ports. And here whenever it is giving the information of address of memory or input output port, it is acting as a address bus, and whenever it is reading the data or writing the data into the memory or from the memory, and then that same bus is acting as a data bus. And the third important function of 8086 microprocessor is that bus interfacing unit is reads the data from the input output port. And the next important important feature of the important function of bus interfacing unit of 8086 microprocessor. It writes the data into the memory or input output ports, and again it supports the instruction queue. That means whatever the instructions fetched by the bus interfacing unit, it will be held in the queue. That is it is a instruction by 6 instructions will be fetched from the memory, and it will be held in the instruction stream byte queue. It will be taken by the again execution unit. And coming to the, in order to perform all these functions, bus interfacing unit required to have some segment registers and pointer registers, some summer we need to have. So to perform all these functions, the bus interfacing unit required to have some segment registers and some pointer registers, and it requires to have the instruction stream byte queue, and then only it can perform all these functions. Here we are having some segment registers, and these 4 registers are named as segment register. These 4 registers are named as segment register, that is code segment registers, stack segment register, data segment register, and extra segment registers, and these 4 are named as segment registers. And in the description of pin diagram we have discussed some selection lines, that is S0 and S1, and based on the combination of S0 and S1, and the processor is going to use any one of these segment register. Whenever that is 00, that code segment register is going to be accessed by the processor. Whenever that is 01, and the extra segment is going to be used. Likewise, we have discussed the 4 combinations of that status signals S0 and S1, 00, 01, 10 and 11, and during that 4 combinations, and these 4 segment registers will be used by the processor, that is nothing but here the bus interfacing unit, and these 4 are combinedly named as, that is segment register. And here we are having some pointer registers also. Pointer register, there are 3 pointer registers, in which 1 is there in the bus interfacing unit and remaining 2 are there in the execution unit, and that register is named as index pointer. This register is named as index pointer, and this bus is a bidirectional one, and here this is going to fetch the instructions, and that will be held in the instruction queue for the next execution, and these instructions are named as pre-fetched instruction. Wherever current instructions are executing, if the processor fetches the next instructions for the next operation, and that instructions are named as pre-fetched instructions, and these pre-fetched instructions taken by the execution unit while it is executing the current instructions, and this process is named as, we already discussed, that is pipeline. So that in order to accomplish all these functions, and this bus interfacing unit requires to have segment registers and pointer registers, that is instruction queue, and some control system, and we require to have. And coming to the next one, that is execution unit. Execution unit, it indicates that it is going to execute the instructions which are fetched by the bus interfacing unit. It takes the instructions from the instruction queue, and so that it is going to execute that instructions, and mainly this execution unit is going to perform the 3 functions, and this execution unit is going to tell the bus interfacing unit from where it has to fetch the instruction, from where it has to take the data. That is the first functionality of execution unit. Execution unit tells to the bus interfacing unit from where it has to fetch the instructions, from where it has to take the data, and this is the first function of execution unit. Second function of the execution unit, by using some decoder, that instruction will be decoded by the execution unit, and after decoding that instructions, it is going to execute the same instruction. And these are the three main functions of the execution unit. First one, it tells the bus interfacing unit from where it has to fetch the instructions. And the second function of execution unit, it decodes that instructions, and after that it executes the same instructions. And to perform all these three functions, it requires to have some general purpose registers, some pointer registers, some index registers. It requires to have some flags, it requires to have some operands, and it requires to have some ALU. And the execution unit not only execute the instructions, also perform some arithmetic and logic functions also. And here, and to perform all these functions, it requires to have the general purpose register, pointer registers, index registers, ALU and flag registers we require. Whereas to perform the all the functions by the bus interfacing unit, it requires to have the segment registers and instruction queue, and it requires to have some summer and control system. And we know that in the 8086 microprocessor, we have studied the features of 8086 microprocessor. Internally, this 8086 microprocessor is having the 14 16-bit register. That 14 16-bit registers are classified into 5 types. First one is a general purpose register, and these 4 are named as general purpose register: accumulator register, base register, code register and data register. Each is a 16-bit wide, so that it will be divided into 1 byte width, so that we can have the two 1 byte width register, that is AH and AL. AH is nothing but this is accumulator higher byte register, this is accumulator lower byte register. Coming to the next case, next register in the general purpose register, that is base register, and the base register is denoted with BX, but internally that is divided into 1 bit wide registers. It is BH and BL. BH is nothing but base higher byte, base lower byte. Here code higher byte, code lower byte, and the next one is data higher byte and data lower byte. And these 4 are combinedly named as general purpose registers. And coming to the next one is we are having the 2 more registers, that is stock pointer and the base pointer registers. And there are 3 registers in the pointer register, that is index pointer, stock pointer and base pointer. And 1 register is there in the bus interfacing unit, and the remaining 2 registers are there in the execution unit, that is stock pointer and base pointer. And the next 2 more registers are there in this execution unit, that is source index register and destination index register. Along with these registers, some flag registers also there, and to execute the instructions which will be fetched by the bus interfacing unit. So in internal architecture of 8086 microprocessor, it has the 16-bit registers. There are 14 16-bit registers, and that 14 16-bit registers are divided into 5 categories. First one is general purpose register, in which we are having the 4 register, and next one is segment register, we are having the 4 more registers, and next one we have the index register, 2 registers are there, and the 4th one is the pointer register, that is 3 pointer registers are there. Then the last classification of these 14 16-bit register, that is flag registers. Already we have discussed this general purpose register, segment register, index register, pointer register, flag registers. I am going to explain the same again. And here there are 4 general purpose registers, that is denoted with A, B, C, D. A is nothing but accumulator register, and it is each 16-bit wide, and it is divided into 2 bytes, so that it is higher byte of accumulator register, this is lower byte of accumulator register. This is 8 bit and this is also 8 bit. Total it is a 16 bit, and it is a base general purpose register and code general purpose register and data general purpose register. There are 4 general purpose registers: accumulator, base, code and data. And coming to the segment registers, and we have the 4 segment register: code segment registers, data segment register, and extra segment registers and stack segment registers. And this will be different selection of these register will be defined by these status signals, that is S0 bar and S1 bar. We have studied this one in the pin diagram of 8086 microprocessor. And coming to the index register, there are 2 index registers: source index registers and destination index registers. And coming to the next register, that is a pointer register, that is instruction pointer, that is a base pointer and the stack pointer register. These are the 3 instruction register, pointer register. And the last one is about the flag register. And in coming days we are going to study the functionality of all these registers, each and every one, and so that we have to concentrate more on the register organization of 8086 microprocessor. Thank you.